Dear student, now we are going to discuss the topic of retrorefractive array. So first we are going to discuss about the introduction part of retrorefractive array. First we should know what is the definition of retrorefractive array. So an antenna array that automatically re-radiate a signal back in the direction of source without complex digital signal processing or direction of arrival estimation. So in that, so you might learn in your previous classes about the refractive index of signal. Yes, the same principles only here also implemented. So that is, so whatever the signal radiated from the antenna, that will be re-radiate back to the direction of the source. So here the core principle is phase conjunction. So the phase of the received signal is reversed at each element. So the retransmitted waves some constructively at the original source. So whatever that received signal you are receiving at the each element, that will be retransmitted to the source of your element. So here the key advantage is we can do the real-time tracking of fast-moving targets with minimum power and also hardware overhead. The next part is we are going to discuss the types of retrorefractive array. So there are two types of retrorefractive array. The first array is active retrorefractive array. The second thing is passive retrorefractive array. The first thing we are going to discuss about active retrorefractive array. So in that we need to integrate active components like mixers and amplifiers into the signal path. So that is the concept of active retrorefractive array. Here we are involving the principle of heterodyne mixing of signal. So here the core principle is heterodyne phase conjunction. So signals are mixed with your local oscillator at twice the carrier frequency to produce the conjugated signal. So here if your carrier frequency is omega means we need to mix your local oscillator minimum of 2 omega. So what are the advantage of this active retrorefractive arrays? The first thing is gain. We can amplify the return signal for long range communication. And the second advantage is frequency shifting. It allows the full duplex communication, it receiving on one frequency and transmitting on another. So this is the main two advantage of active retrorefractive array. The next thing is we are going to discuss the second type is passive retrodirective array. So what is the mechanism here? We are using fixed transmission lines of equal length or specific wavelength multiplies to connect pairs of antenna elements. So here the example of this passive retrodirective array or the common type of this passive retrodirective arrays are band and auto array. So here we are doing symmetrically pairs elements around the array center, and also we are connect pairs with equal length lines to achieve the automatic phase reversal. So here the core principle is phase reversal concept. The core principle is phase reversal concept. And here the characteristics of this passive retrodirective arrays are we are using the same frequency. The return signal is at the same frequency as the incident wave, but the previous one we are using different frequency. And here that another important characteristics is here there is no power needed for our passive operation. So now the next thing we are going to discuss the diagram of this retrorefractive array. See here, we are having this phase difference reversal circuit here. See here that incident way and the reflective way. So based on our application, we can apply the phase value to incident and reflected part. The next thing is we are going to discuss about the application part of this retrorefractive array. Here there are 5 different applications for that. The first thing is we can use for beam steering toward ground station without complex altitude control system. So that in practical they are using in CubeSat and LEO satellites. And also the next thing is inter-satellite links. And the third application is physical air security. And the fifth application is millimeter wave application. So the next thing is